what powers an electric car? I know, it's not really a very in-depth question at face value, and if you said an electric motor, you'd get a big tick on your homework from me. If you said an electric motor, which in turn gets its power from a battery pack or hydrogen fuel cell stack, then you'd be getting a gold star too, and maybe 5 minutes of extra time at recess. Do they still do that anymore? But don't pat yourself on the back just yet, because like there are many, many different types of internal combustion engine in use today, there are different types of electric motors in use across the auto industry and beyond. Some are built from power, some are built for speed, and others are built for efficiency. Sometimes you'll see motors built from a combination of the above. So today we're going to take a little look at some of the electric vehicles on the road today and figure out just what type of motor powers them. And if you're interested in the basics of how a motor works, why they're better than an internal combustion engine for powering cars, and some of the differences between the various motor types, then head on over to Answers with Joe, who's joining me on this collaborative, electrifying tour of electric motors. If you want to go and watch Joe's video and come back here when you're done, that is totally fine. Or you can watch this one first and then go watch his. It's one of those times when it really doesn't matter which order you get the information in, as long as you get it. Before I delve in with both feet, I just want to touch on the whole AC-DC thing. And no, we're not talking rock here. Today, the majority of electric vehicles on the market use alternating current or AC motors, in which a special controller calculates just the right amount of alternating current to send to the motor's coils in order to keep the whole thing moving at the right speed and in the right direction. But it wasn't always the case, because math is hard, and while fixed speed alternating current electric motors have been around for years and years, and AC motor design makes for a lower cost, lower maintenance motor when compared to a similarly powered DC one, building a variable speed alternating current motor is pretty darned hard to do, and only really practical in today's modern age of integrated circuits and computerized controllers, because computers are good at math. Go back 120 years to the first generation of electric cars, and you'd see series wound DC motors in use. They were good for delivering a high amount of torque from standstill and got up to speed pretty briskly. However, because the torque of a DC motor is proportional to the speed of the motor, there's a pretty noticeable drop-off in power as the motor spins faster, which means your 1910 Baker Electric may not climb that hill as quickly as it sped along the flat. But don't think that means DC motors are rubbish and should never be used. No. The oldest space electric vehicle in existence uses DC motors because of their simplicity and fantastic torque. No, I'm not talking about Elon Musk's personal Tesla Roadster, as driven around the sun once by Starman. I'm of course talking about the lunar roving vehicle as left on the moon by Apollo 15. The moon buggy, as it is now known, used a quartet of DC motors, one in each wheel, to get it around the challenging lunar terrain. Sure, it wasn't fast, but it and its two siblings, also parked on the moon, did seem to get the job done. If you were in the UK sometime around the turn of the last century, you may have noticed a large number of gee-whiz electric cars roaming the streets of London. Built in India by a company that was eventually acquired by Mahindra, early gee-whiz cars, which were built for efficiency and low cost, used DC electric motors at first, but then switched to AC motors when motor controller technology got to the point where it was cost-effective and better to use AC motors instead. Remember, AC motors are generally better than DC. But you're not here to listen to me wax lyrical about old electric cars, even though I will, and I've owned some pretty amazing ones in my time. No, you want to know about the motors that are in cars that you can buy today. The majority of automakers on the market use some form of permanent magnet synchronous motor for their electric vehicles. And I say the majority because while each manufacturer may have a slightly different name for it, they all generally make use of the same basic design and principles. Why permanent magnet motors? Well, they're lighter and more efficient overall, but they do have some downsides, namely the fact that they rely on rare earth metals in order to function. You'll note that I use the term some form because not all permanent magnet synchronous motors are exactly the same. Some automakers, including Nissan and Chevrolet, use what's called an interior permanent magnet synchronous motor. They put the rare earth metals that form the electromagnetic field that interacts with the motor's coil in the rotor, and then they put the coil in the stator. This not only makes it easier to build, but it means there's less chance of the motor self-destructing, and it also means that you can do neat and crazy things with the motor windings, like use square wire. No, I am not kidding you. The Chevy Bolt EV's motor uses square wire in its windings, which allows more wire to be packed into a given space, increasing the motor's power while decreasing its overall physical size. BMW doesn't exactly use a bog standard permanent magnet motor in its i3 either. It uses something it calls a hybrid motor, which uses permanent magnets in its design like a permanent magnet motor, but it's also built to take advantage of the reluctance effect of a reluctance motor. It effectively takes the best bits from both motor designs and manages to pump out a much higher power output than your bog standard permanent magnet motor for the same physical size. Which of course brings us to Tesla. While most of the rest of the auto industry were focusing on permanent magnet electric motors, Tesla chose to use an AC induction motor instead. It's kind of fitting really, since, you know, the father of the induction motor being called Tesla, the person that the company was named after. The original Tesla Roadster, the Tesla Model S, and the Tesla Model X were all designed to make use of an AC induction motor, using a three-phase, four-pole design. They were capable of great versatility, and the lack of permanent magnets in those motors was a bonus for Tesla as a startup, as it didn't have to worry about paying eye-wateringly high prices for rare earth magnets, which kept its build costs low. But while AC motors are, outside of the auto industry, the most commonly made motor, they're larger and not quite as energy efficient as some other designs, despite being able to spin at crazy high speeds and offering really impressive torque at startup. That's what gives the Model S its acceleration. Which brings us to the Model 3 and its permanent magnet synchronous reluctance motor, which, to be honest, sounds a lot like the motor that BMW uses in its i3. In a synchronous reluctance motor, there are electromagnets around the motor's stator, the bit that stays still, and the rotor itself is made of a non-magnetic material interspersed with veins of magnetic materials, which means that the rotor will turn to a preferred orientation when there's a magnetic field applied by switching the stator's electromagnets on and off. It's more efficient than the AC induction motor, and it's also the cheapest type of AC motor to make, which is a bonus when you're trying to make a mass-market affordable EV. But it's also not so good at high power acceleration from standstill because it doesn't produce as much torque as some of the other motor types at lower RPMs. Which is why Tesla has gone the hybrid route for its Model 3 dual motor, and more recently, the Model X and the Model S. These all-wheel drive Tesla variants have two different types of motors, one for each axle, allowing the cars to have blistering performance when desired from the AC induction motor and long legs and efficiency when required from the switched reluctance motor. So there you have it. Those are the different motors powering your EVs today, and I didn't even get to motorbikes. Maybe that's another video. Thanks to Joe for working with me on this collab, and if you haven't seen his video yet, go check it out now. The link's right here. That's it. Thanks for joining me, and I'll see you next time.